Have you ever really thought about the ground you're standing on? I mean, it feels solid, right? Like it's permanent. But the truth is, our planet is constantly moving, driven by these incredible unseen forces deep inside. Today, we're going to pull back the curtain on that hidden engine that shapes our entire world. Okay, let's get into it. So this is the big question, isn't it? Why does our planet, which feels so stable most of the time, suddenly unleash this unbelievable, violent energy? Well, to figure that out, we're actually not going to start with the cause. We're going to start with the effect. So yeah, let's start right here, on the surface, where these movements become all too real. And to really grasp the scale of what we're dealing with, we're going to look at one specific, terrifying event. January 26, 2001. Imagine, it's just a normal day in Bhuj, India. And then, in an instant, it's shattered by a massive earthquake. This one event is such a powerful and tragic example of the kind of energy that's just waiting right under our feet. You can just feel the chaos unfolding in real time here. The impact was instant, and it was devastating. In just a few hours, the entire city was crippled. I mean, look at this. School buildings, the places that are supposed to be safe, just gone. The basics we take for granted, power, water, knocked out, leading to even more danger with fires. And then, in the days that followed, you see this second disaster unfolding, the desperate struggle just to get help to the people who needed it most. So, all that destruction in Bhuj, that was the symptom. Now, it's time to find the cause. And to do that, we have to go deep, deep inside the Earth to find the hidden engine that's driving all of this. You see, the surface of our planet isn't one solid shell, not at all. It's actually more like a giant, cracked eggshell. It's broken up into these enormous, rigid pieces called lithospheric plates. And these things are huge. They carry entire continents and ocean floors. And the wildest part? They are always slowly on the move. Which, of course, leads to the next big question. What on earth is powerful enough to push around a slab of rock the size of a continent? The answer, once again, is deep inside the planet. Okay, this is a brilliant way to picture it. You heat a beaker of water from the bottom, right? The water down there gets warm. It expands, and it starts to rise. When it gets to the top, it cools off, gets denser, and sinks back down. It creates this constant circular current. And that little paper pellet, it's just along for the ride, carried by the moving water. Now just scale that way, way up. The beaker is the Earth. The water is molten rock, magma. And the heat source is the Earth's core. You get the exact same circular motion, these massive convection currents churning deep in the mantle. And those lithospheric plates we talked about? They're just like that paper pellet, floating on top, being dragged around a few millimeters every single year. So you have this super slow, steady movement happening over millions of years. But all that slow pushing and grinding builds up an absolutely incredible amount of energy. And when that energy finally lets go, well, it's anything but slow and steady. Geologists basically put all the forces that shape our world into two big categories. You've got exogenic forces, things like wind and rivers that work on the surface. But the ones we're interested in are the endogenic forces, the ones that come from inside the Earth. These are the forces that slowly build mountains and, you guessed it, cause earthquakes in the blink of an eye. And there it is. That's what an earthquake is. It's the vibration you feel when those giant plates, after getting stuck and pushing against each other for years, suddenly slip. All that pent-up energy is released in a single moment, sending shockwaves racing through the ground. Let's quickly break down the lingo. The focus is the actual spot deep in the crust where the slip happens. The epicenter is the point on the surface directly above the focus. That's usually where the most violent shaking occurs. And the seismic waves, that's the energy, the vibrations, spreading out from the epicenter, just like ripples when you throw a rock in a pond. So we've established these are massive, powerful events. But how do we put a number on it? How can we possibly measure something that powerful? Well, scientists use a really sensitive machine called a seismograph. It's designed to detect and record these seismic waves, even from thousands of miles away. And the data it collects lets them assign a number on what's known as the Richter scale, which tells us the earthquake's magnitude, or its raw power. Now, this is the really critical thing to understand about the Richter scale. It's not like a ruler. Each whole number you go up represents 10 times more ground shaking. So a magnitude 7.0 doesn't just feel a little stronger than a 6.0, it shakes the ground 10 times more intensely. It's a huge leap in destructive power, which is why you go from a little tremor to a major disaster so fast. And that 7.0, that's the number that officially classifies an earthquake as major. This is the kind of event that can cause widespread, catastrophic damage. Remember Buj? It was a 6.9, right on the cusp of being a truly major, city-leveling disaster. So we get what causes them. We even know how to measure them. But here's the one thing we can't do: predict them. And that brings us to maybe the most important part of this whole story. How do we live on a planet with this kind of unpredictable power? And this, right here, is the key. Despite what you might hear about animals acting weird or other theories, there is just no scientifically proven way to predict exactly when or where an earthquake will hit. Our only real defense isn't prediction, it's preparation. Knowing what to do can literally save your life. So let's do a quick mental drill. The shaking starts right now. What's your move? Where do you go? Okay, your first move is to get under something sturdy. A strong desk or a kitchen table can shield you from falling objects, which is one of the biggest dangers. If you can't get under something, get against an interior wall, away from the outside of the building where things are more likely to collapse. And knowing what to avoid is just as important. Get away from windows. They can shatter. Steer clear of fireplaces and chimneys. They can easily crumble. Even things hanging on the wall, like mirrors or big picture frames, can become dangerous projectiles. You want to get as far from those hazards as you can. And that brings us full circle with a much deeper understanding, but also a really profound question. We live on these colossal, moving plates powered by this unstoppable engine inside our own planet. We know why it all happens, but we'll probably never know when. So the real challenge for all of us is to figure out how to build our future, not fighting against that power, but respecting it.
Welcome! Today we are diving into the powerful, almost invisible forces that are at this very moment sculpting the ground we walk on. I'm talking about the true architects of our world, and their work is happening all around us all the time. So let me ask you a question. That ground beneath your feet, you think it's permanent? We tend to look at mountains, coastlines, and valleys as these fixed, unchanging features. But the truth? The Earth's surface is in a constant state of change. It's like a slow-motion dance of creation and destruction that's been going on for billions of years. So, who are these sculptors? Well, they aren't artists with chisels and hammers. They're the relentless forces of nature itself. We're going to explore how these agents, water, ice, and wind, are constantly wearing down and building up the landscape, creating the incredible world that we get to see. Okay, first things first. We've got to get this crucial difference straight. You've got weathering and you've got erosion. Think of weathering as the sledgehammer. It's the process that cracks a giant rock into smaller pieces. But then comes erosion. That's the cleanup crew. That's when water, wind, or ice shows up to carry all those smaller pieces away. It's simple. Weathering is breaking, and erosion is taking. This is the key to everything else we're about to see.
And here's how the whole process fits together. It's a four-step cycle. First, weathering breaks the rock down. Then erosion starts moving the fragments. That material gets transported, sometimes for hundreds of miles. But, that journey has to end somewhere. When the energy runs out, the material gets dropped. That's a process called deposition. And that, right there, is the magic moment where new landforms are born. So the really cool thing is, destruction in one place actually leads to creation in another.
All right, let's start with our first and maybe the most powerful architect of them all, water. I mean, from a single raindrop to a massive river, water is on a constant journey, and it's carving its signature into the landscape every single step of the way.
One of the most dramatic things a river creates is, of course, a waterfall. This happens when a river hits a layer of super hard rock. The water's power just carves away the softer rock underneath it way faster, creating that spectacular vertical drop that we all know and love.
And speaking of spectacular, while there are thousands of waterfalls out there, the undisputed king is Angel Falls in Venezuela. Seriously, to put it in perspective, it is more than 15 times taller than Niagara Falls. Just an incredible display of water's raw power.
So what happens when a river gets a little older and hits flatter ground? Well, it starts to get lazy, snaking back and forth in these big looping bends called meanders. Over time, the water erodes the outer banks and drops silt on the inner banks, making those loops curvier and curvier.
Then, one day, maybe during a big flood, the river takes a shortcut. It just punches a new, straight channel right across the narrow bit of land, and boom, the old loop gets cut off, left behind is this beautiful crescent-shaped oxbow lake.
Okay, so at the very end of its long journey, the river finally meets the sea. And here, it slows down so much that it just can't carry its heavy load of sand and silt anymore. So what does it do? It drops everything. All that sediment builds up, layer by layer, and forms a delta, a brand new piece of land literally created at the river's mouth.
But water's work doesn't stop where the river ends. Oh no. Now we turn to the immense power of the ocean. The constant, relentless crashing of waves against the shore is another major force of sculpting.
And it all starts small. Waves will find a little crack or a softer spot in a rocky cliff and just start hammering away at it. Over thousands of years, that hammering hollows out the rock and forms a sea cave. Now, if that cave forms in a headland, a piece of land that juts out into the sea, the waves can eventually punch all the way through to the other side. The cavities get bigger and bigger until only the roof is left, creating this stunning natural bridge we call a sea arch.
But the story's not over yet. That same relentless erosion keeps weakening the roof of the arch until one day the whole thing just collapses into the sea, and all that's left standing is a tall pillar of hard rock, totally isolated from the coast. That's what we call a stack, a lonely monument to the sheer power of the waves.
So, we've seen liquid water. Now let's talk about solid ice. Glaciers might move incredibly slowly. We're talking inches a day, but don't let that fool you. They are some of the most powerful shapers of the land on the entire planet.
Honestly, the best way to think about them is as giant bulldozers. As these massive rivers of ice grind their way downhill, they scrape away absolutely everything in their path. Soil, huge boulders, you name it, carving out deep U-shaped valleys and exposing the bare bedrock underneath. So what happens to all that stuff the glacier bulldozed? Well, it gets carried along for the ride. And when the glacier eventually melts and retreats, it just drops everything it was holding. This huge, jumbled pile of rocks, sand, and silt is called a glacial moraine, and it creates these ridges and hills in the landscape that tell the story of where the ice once was.
For our final architect, let's look at something we can't even see, the wind. Especially in dry places like deserts, where there isn't much vegetation to hold the ground together, wind becomes this major artistic force. And here's a fantastic example of the wind's unique style. See, wind can't lift heavy sand particles very high off the ground, so it basically acts like a sandblaster, eroding the bottom of rocks way more than the top. And the result? You get these incredible mushroom-shaped rocks with skinny bases and wide overhanging tops. And just like water, when the wind finally slows down, it has to drop the sand it's carrying. This is how we get those iconic shifting sand dunes. But sometimes, if the grains are super fine and light, almost like dust, the wind can carry them for enormous distances. When this fine material gets deposited in huge, thick layers, we call it loess, and it can actually form incredibly fertile soil.
So, we've journeyed with water. We've seen the power of ice and felt the breath of the wind. Let's pull it all together and think about what this really means for our planet. So here's the big picture recap. We've seen how rivers are both carvers and builders. We've seen how sea waves are master sculptors of our coastlines. We've seen how glaciers are the planet's unstoppable bulldozers, and how the invisible wind can shape both solid rock and mountains of sand. Each one leaves its own distinct signature on our world. And this is the main takeaway. The world you see outside your window isn't finished. It's not a static canvas. It's a dynamic, living sculpture, and it is constantly being reshaped by these incredible natural forces.
And that leaves us with a pretty cool thought, doesn't it? These forces are still at work, right now, every second of every day. So the next time you see a river flowing, or feel the wind on your face, or stand by the ocean, remember the immense power you're witnessing. It really makes you wonder, what great landform is being born right now? What will our planet's next masterpiece be?